Hey everyone, we're going to be doing a DMOJ contest today. This one is yet another contest 9, and this is a bit of a harder one than like the past 2 contests I've done, so it's hard to say what my like criteria for like doing good is. I suppose like if I can solve like 4 problems and get subtasks on the other 2, then I'm in a pretty good spot. So let's aim for that. Anyway, first problem. Okay. Okay. Looks fine. I mean, knowing DMOJ, this has an edge case, but let's go with it anyway. There's no test cases here. What am I talking about? Okay. Okay. Let's see if this works. Okay, I think that's it. Okay, cool. Yeah? Okay. Let's go to problem 2. Josh is bored of playing NIMS, so he has decided to make his own variant. He will play against Mike with the following rules. There are n piles of stones from 1 to n. Oh, interesting. Okay. So the game is unchanged if all are 1. Let's say there's all 1s and 1, 2, right? So the other player wants the number of... Basically, you're losing if the number of 1s is even. You win if it's odd. So if there's a single 2 there, what do you want to do? I think the game is actually flipped. I don't know. I have to take notes here. This feels funny, but I think it's true, honestly. Okay, it's not that. Interesting. So, if there's no ones, then what happens? It's just kind of like whatever happens, right? Until you're like with one left. Let's say you have two piles left, right? What's the correct thing to do? If both of them are not one, then it reduces to a smaller case. Let's say one of them is one. It's not Missirnim, but it's something interesting. Oh wait, actually, something doesn't seem right. If it's all, the first player should win, right? Oh, but it's not. If you just have one thing left, and it's non-zero, then you don't win, you lose. This actually does require some thought here. I don't know. What happens? If I pick one, then I can win. If I pick this, this feels weird, but let's try. Yeah, that's it. Oh, that's pretty silly. Okay. Okay, this one. Let an array be good if and only if you can make it empty by performing any number of the following two types of operations. Interesting. Okay. Let's do input. So single array. All right, so it's like, okay, when is an array good? The thing is like, you want to repeatedly take the last element for which you can do an operation and do it. I think that's true. Or just do all the operations you can, in fact, and then perform moves. Like, does it ever benefit you to not do an operation when you can? Not really, no. Like, let's say like the optimal thing to do is to wait until it's earlier and then do it then. No, I think I'm pretty convinced that it's always optimal to do a division when you can. In which case, then what happens? And then like remove the first one, right? The thing is, an element will visit every index that is before it. So as long as it's divisible by everything in that range, then it's fine. Okay, sure. So it's like for each element, if I am inside the subarray, then the index has to be at least yay back. So okay, so now what? Okay, I see. I see. I see. I see. I see. I think seg tree is useful here. I don't know, actually. I think technically it's not actually. I think maybe they're gonna be cute and like require you to use a stack, but anyway, what the first piece of information you need is like the smallest prime fact, the largest prime factor of each value. So you can just pre-compute that, I guess. All right, cool. So now what? You should store for each index like the furthest back it can go. So that helps. Do I need segtree here? Can I get away without using segtree? Ah, no. I think they're gonna actually be pretty annoying about it. I think you have to do the stack thing. Yeah, it's fine. And find the last, then it'll be something like, yeah, anyway. So while not empty. All right, so yeah, so num all right. Lower bound means, okay, yeah. Yeah. One is interesting. Just say LPF1 equals 1, why not? Okay, so there might actually be a much easier implementation here. No. This is no. Yeah, this is fine. Okay. So, hold on. No, this is correct. Okay. Okay. All right. Yeah, let's see if how this works. Okay. Kind of expected that. Let's see at what index it messed up on. The funny thing here is that, like, no. This is actually entirely fine. So it failed at 0. So it would have happened here. So it would have done this. This is how it would work. Okay, no, this I have to think actually. Okay, no, 1 can just be extinguished. Okay, no, this is fine. Okay. That's 5. Okay. It got the sample correct. If this was, then I might just implement the subtask. I might. Oh, okay. AC. Cool. So, what are we on? Problem 4 now? Okay. Oh, combinatorics. Oh, how cute. Okay. This looks fun and also might require a lot of thinking time, so maybe I should skim these first. It's a constructive, okay. And I won't even look at P6. Let's just try to solve this. I don't understand this, but okay. Oh, you have arrays. Okay, I see. With no zeros that can be created. Okay, fascinating. Yeah, fascinating. Let's think. I think like let's just take an input. So we have n and two arrays, right? And they're all in 2n. Yeah, let's subtask 1 is the binary version of this problem. The thing is, like, if I push, like, if I have a configuration of the grid, right, then I push a column, then a sub array of it still remains. So that's the interesting thing, right? Like, subsegments kind of continue to exist. So if a row was ever pushed, then depends on what happens in the future, but is it just like a staircase type thing? I don't even know. Yeah, like a prefix will just be like shifted like that, right? I'll only ever be pushed down by another row. So it is like a staircase, basically. Oh, okay. Okay, so there's that, but then there's like, okay, for each staircase, how many ways can they look different, basically? It's very interesting. I mean, you'd have to do like some string algorithms, right? In order for like such a thing to work. Yeah, wait, this condition of them having to be different is it's very string algorithm. Like, you need some string weirdness, like some KMP algorithm nonsense in order for this to work. Like if we had the case that like, oh actually we have subtask 1 now. We have subtask 1, so there's that. I can just code that up, honestly, to see how it works. Because it just pads on a grid, right? So it's like n plus n choose n or something. Yeah, this is just 2n. Let me just copy my combinatorics. Let's see if this gets 30%. No? Huh. Oh, I fucked up the mod. Okay. Let's try again. Okay. So I have 30. But that doesn't, okay. I mean, there's that, but now how do I do the string algebra component of it? When are two staircases the same? That's like the weird thing. So the top one has to be the same, right? So that means just that like, this is only even possible if like a prefix of this is all the same thing. So that's very interesting. And it'll only shift back like this. Yeah, I think it has to be the case that all of them are the same, actually. So, wait, this problem is so stupid. Wait, this is not even a hard problem. What? This is such a stupid problem. you have to accumulate this, right? So it's like, find the first row between two equivalent things that's different, right? It has to be the case that the prefix used in that is just all ones. So, and once it's all ones, then I think what you should constrain it to is like, once it's all ones, don't ever like move it back further. Just like keep it like that. Okay. Get on my iPad actually. I want to draw this out. Alright, I kind of just want this to marinate in my head as I think about P5 a little bit. So let me think about P5 a little bit. Because I'm quite confident I will eventually solve P4, so it doesn't really matter. So this is just a tree with an edge. Oh, this is just tree swapping. Hold up. I think I just know how to do this. I don't know why, but this problem just doesn't look hard. This problem looks quite straightforward, in fact. But I don't know. I might be very wrong about that. So let's go back to D. I want to finish off this problem. So I just need to draw a diagram. So I'm going to do that on my iPad here. So when would this be equal to something else? It's like, What would have to be the case is that this is A. Which means that this is A also. And then in the bottom one, right, that means this is A as we established. It would have to be the case that moving these up didn't change it, right? Which only happens if it has a period of that much. Okay, this is a little tricky actually. I don't know. So a shift is only ever possible if it's all just ones here. So that we've actually established, but now we have to go through this second criterion for when this is possible. And that is if for each column there will be like a difference in when it first appears. That difference has to be divisible by the period of B. That's actually really interesting. Because if B is all the same, then I mean, if B is all the same and A is all the same, then like the answer is 1. Otherwise, it has to be something like for like 3, right? The cut across each thing has to be divisible by the period. Which is very interesting. So A just puts a constraint on how much it can be. B puts a constraint on. Okay. Might be acting stupid though, because like it's not even really period. It's like it's quite interesting what has to happen actually. Like it has to go up in a way that's periodic, but what else? It's like if there is a shift back here and like a shift forward here, there's some very tricky like constraints about B, right? Or no. That's actually is not relevant anymore. So but I think it has to be symmetrical, right? So for a column, if a row is different, then like a column is also different. Meaning okay, my thoughts are getting a little bit like chaotic. Gotta sit down, calm down. Let me draw another picture. I think it's good to be concrete about this. But what if it's something like this now? Three becomes 2 2. Then what? That means this column got shifted down one. Okay, let's draw this picture. I'm gonna erase it here. I see what the conundrum here is. If a column shifted up to a bunch of A's. So it has to be the case that this entire prefix was also just A's. It's very fascinating. Because like if this is A, I think you can just like make an argument here. Yeah, I think it just carries down. So it's like how many prefixes of these guys are just the same letter? Okay, I guess. Okay. We have this one case now. It's just prefix of both is all ones. That is the funny case. So we have to just subtract that out somehow. How do we do that? There's just like certain corners of the grid that are gonna be monochrome if that is where the turning point is. So I feel like it just ends at that moment. Yeah, it's just like the moment that this hits all ones, or this hits all ones, then that's it. And then it's still those binomial coefficients. Okay, I mean that's fine, I guess. Nothing egregious. Now what is it? It's like... well, you can give this a shot, I guess. No, this isn't quite correct. I mean, this would make it past the case, yes. Really? All right, no, this I have to be more scientific about this, unfortunately. It's like you have a grid, right? And you have this like corner here. The moment you hit this, it's just monochrome from there on. Oh, I see what the issue is. It's like... Oh, God. It's still path counting, but it's like weird. Because, like, it still was like meaningful if you change something. Okay, I kind of see. It's like... It's like I add a bunch of stuff. It basically just means that you can't ever go inside this, like, thing anymore. So let's apply that drawing to, like, this one right here. It's 2 by 2, right? It means like that this edge is gone, for instance. It's a very weird palette counting problem. It's like, oh, okay. This is actually fine. Actually, not quite. Oh man, dude. Why don't I know how to do basic counting? I guess it's like either I go through here or here, right? Okay, is that gonna fix it? No, that doesn't actually fix it. All right, that's it. That's what it should be. Okay. This should also be correct now. Yeah, okay. Let's try it. Oh, man. Oh, that's not it? Oh, dude, that's why. Oh, man, okay. Pretend that didn't happen. Okay, let's go. Holy crap. Okay, beautiful. Okay, I'm actually proud of solving that. Oh my god. I'm proud. Dude, oh my god. I don't know if this is like supposed to be that hard. Maybe to the mathematically oriented mind, this is standard, but oh my goodness. That actually felt so good to solve. Oh my god. Okay. P5. I can look at both P5 and P6 now. I feel justified in doing that. Is this also combinatorics? I think it's just data structure. Okay. Okay, for this problem, I have a solution. I seriously cannot tell if it's like bad. You get 50% if you have just like a construction, I believe, right? Okay, so if you have a construction, you get 50. If you have the optimal, you get 100. Okay, sure. Dude, wait, I don't know. I'm still reeling from like that D-solve. That felt so good. But anyway, let's do this. You can erase the combo template. We don't need it anymore. Okay. Let's do input. Okay, I think the way in which I input stuff is heavily like dependent on like what my solution is. So let's like think about what that is at first. This is like a tree DP or something, probably. Okay, I see the difficulty in this now, because you care about the ordering of the edges. Okay, that... sure. You want... okay, yeah. No, actually, you don't care about order at all. Let me just draw this example out. So you want to transform this into this, right? How do you do it? I guess, I think you just do like... All right, so it's very easy to show that like a swap is always possible. So I think like the curious thing here is that like you have an extra edge. And like you want one tree to turn into the other tree. If they have an edge in common, then problem solved. But if there's no edges between them in common, you case on that first edge. And then you do it. I don't know. This doesn't feel hard for some reason. Okay, yeah. So you just case on the first edge that you turn on. Oh, but like, this. Okay, there's weirdness in this problem, so I have to think. Let's just get the 50 points. Let's just get a solution. Yeah, let's just get a solution. Let's not try to be optimal here. If I can get 450 points, then I will be in a more comfortable place to think about the rest of the problem. So, yeah, let's just write it. So for each, okay, no, not, n is 100, so you can like be really goofy with your complexity. It's fine, so let me just copy DSU here. All right. As long as this terminates, then I will have. Oh, wait. I think I inputted this wrong. Let's fix that. For int I equals 0, cd I is less than n. I don't know why I have to give them separate variable names, but whatever. Okay. Does this work any better? Really? Okay. Well, that's something. You know what? This has to happen first. But in any case, this shouldn't be looping. Let's investigate. Why is it doing that? It is looping. Let's just break after the first go. You know what? E1 has to erase take, doesn't it? Yeah, E1 dot erase. Alright, cool. Oh, I mean, I only went that one time, but let's like see if it actually works. Okay, well, if it terminated, it works. Okay. What? Really? Yeah, wait, why would it wah? That's very interesting. Let's assert found here. I want to see like what it's failing precisely. Oh, okay. So it always thinks it found something. It's just incorrect. Okay, this is kind of bothering, by the way. Let's fix that. Alright, so... yeah, the case here is that if cc equals 2, that's kind of an important thing. Alright, hello. Let's fix you. What? I mean, the deal is just like... wait, no, so this is weird. I don't know why this doesn't work. Dude, what? Huh, this is very weird. This should pass to me. I mean, I can try like other cases, I guess, but it passes the assertion, so like if it passes the assertion, it should provably work. So I must be breaking some other condition here. Or I must be making like a coding error or something. Well, okay, let's just draw out what this did actually, because I don't even understand. 2, 3, 4. First move was 1, 2 with 1, 3, right? So it would have done 1, 3, 4. And then it did 1, 4, 2, 1, right? 1, 2, 3, 1, 4, and 3, 4, 2, 4. That seems to end up with the tree we want. 1, 2, 2, 3, 2, 4, 1, 3. Yeah, no, that's all these moves are correct. So I must be misreading. Oh. Oh. Wait, okay, I misunderstood the problem. Oh, I see. So it doesn't have to be connected after the replacement. It just has to be like connected after the deletion. Oh, okay. Oh, okay, that kind of okay, that changes it significantly. Okay, I was just misunderstanding the problem. Okay. Well, what changes really? It just means that the edge that we remove has to be on the main cycle. That's basically it. So basically the main cycle always has to have an edge that, we don't want. Oh, okay, and that's where it gets like really weird. Because like we have to take something out of the main cycle, and then we make a new main cycle. If for every edge in the new guy, like Well, these guys claim that it's always going to be possible. It can be proven. Well, if it can be proven, then it doesn't matter. We can just do whatever. As long as we make some progress towards the solution, then it doesn't matter. We can just use their little, like, guarantee here. But anyway, you have to take something on the main cycle, basically. Oh, I guess the troubling thing is that it's not guaranteed that we will make progress towards an answer. Okay. That's the part that's not guaranteed at all. Okay. Okay, let me start taking notes here. So we have a cycle of like some white edges, some black edges. Consider like okay, now we're in 12 minutes left. Let's read this. No, let's think more about this. Oh wait, it's very easily provable that like no, it's actually very easily provable. I mean, okay, sure. I have a solution. Okay, it is optimal. It just is optimal. Okay, so it's just like find an edge on the main cycle. And then okay, just do a bunch of nonsense to get the main cycle, and then like move an edge on the main cycle, and then yeah. Okay. Sure, okay, yeah. Do 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 do. Edge on the main cycle, that's like the one hard thing about this. Okay, I mean, you can always just do this the stupid way. Alright, so that's that. Now, I'm just gonna do a really gross thing because I can't be bothered. Alright, so now it's just we have to do the funny thing. Okay, else. Okay. The tough thing is, it's possible that okay, yeah. All right, so the logic here is that if get the same break, just do that immediately. All right. All right, so you have these connected components. Auto UV equals ed. If d.find u yeah. This is the guy that we want to take, right? Okay. Alright, let's see how well this works. $98. Okay, is it infinite looping? That's what I want to know. Okay, it's looping. What is the first move it's trying to make? Three, 4, 2, 4. That actually seems correct. Two, 4, 2, 4. Oh, I see what the issue is. Then it doesn't find it. Okay, I have to inspect this case. And what do we want it to finally look like? Like that, okay. Oh, so, okay, it was just like bad. Okay, I see. What did I just select? I don't know. Okay, so shouldn't 1, 4 also be on the cycle? I see, okay. Now I know that this is just wrong. That's what the issue is. Okay, we're going in I2. Two, 3, so 3, 4, right? So what would the issue have been here? Like, if they're not the same, then you advance just one. Oh ho ho ho. Oh wait, I see. Okay, wait. I know how to fix this. Okay, I see. I see what the issue is. Well, okay, it's doing more now. What? We can't even see anything now. I still want to see how wrong this is. Yeah, come on, come on. On psych 2-3. Okay, so it's still bad. Hold on. Oh wait, it still thinks it's 2 and 3 when it kind of shouldn't. I don't actually understand what's going on here. Oh, I should just get rid of this. That's what the issue was. Okay. Me not knowing how DFS works. That's great. Why is it getting... That's very strange. Why are you swapping out 1-2 for 1-3, then 1-3 for 1-2? First of all, why are you even swapping out 1-2? So 1-4 is not in the final one, right? Oh, hold on. I know one fix. That's important. right? What is it now? This is like the final move, like it should. It wants to remove 3-4, but why is that? Plug this back in. Oh, it feels like I'm close. Oh god, I have to be close. It feels like I'm very close. Either I'm close or I'm going to soon realize like that I made a very wrong step somewhere. One, 4, 2, 4. That is a move. That is indeed a move. So just 3, 4, 1, 3 should finish it, right? Yeah. And then it doesn't recognize that 1, 3 works. So it thinks that 1 and 3 are in the same. That's what it is. Patch after patch, but should just be correct now, yeah. Okay, okay, let's get rid of this. Oh, let's go, man. Let's go. Dude, holy that was garbage code I wrote, and it just shouldn't have passed. It feels illegal that that code passed. Oh my god. Dude. Okay, this contest is going quite well. I must say, this contest is going quite well. I think no, I'll have a very hard time believing that this is not a good performance. It has to be good at this point. Okay, but let's read problem F. We should at least attempt the subtask on problem F. Like the 15% subtask, come on, we should attempt that. Dude, oh my god. There's just no way that works. I mean, of course I proved it to myself, it should have worked, but I'm still in awe. Okay, I understand this problem now. It's just like... It's just like, given a set of observations, you want to count how many... Okay, so for the 2 case, it's kind of simple. It's just like, for the subtree, how many possible centers are there? Okay, I mean, sure, like the n equals 2 case is pretty easy. So let's go for that. Okay, then you just read in the tree. All right, so now what? We have to verify 2 things. One is that the set of like red nodes are connected. This is actually pretty easy to prove. It's just like pretty easy to check. It's just count the number of edges. Alright, I guess it's just like if A of U not equal A of V. No, actually. Alright. Now it's just like... All right, so now it's just like, so if end equals 1, yeah, so now it's just like, all right. Okay, CFS, DFS, E1, E1, DFS, DFS, E2, E2. That's kind of hilarious code right there, but. Six. Well, that's definitely not correct. Huh? Why would this seg fault now? It's very weird. Yeah, this is fine. Woohoo, that would do it. Further, that is important. Okay, I do kind of see a problem here, but it's whatever. Wait, it should have added that. So why didn't it add it? Oh, that would do it. trivial, right? Ah, come on. Come on. All right, get 6. Just submit this. Whoa. So batch 1 is wrong. That's crazy. Okay, so what would be wrong with this? There has to be an issue here because, like, if I do this, does that affect the correctness, really? It does. Do. Okay. Ponder. You know what? I forgot that M was a thing. I forgot that M was a thing. Let's fix that. Nope. That wasn't it. This is kind of weird. I don't know. I feel like I don't know. I feel like this is correct. but I don't know. I'm not sure. Maybe it's not. Do. Oh, hold on. That would do it. Okay, 5:15. I'm pretty okay with that. But we can try to go for 5:30. I'm surprised this is taking so long to run, honestly. Cool. Yeah, segmentation fault. Sounds about right. Wait, okay, now that I think about it, the general problem isn't hard either. I mean, it's definitely not worth getting the 5:30. I don't think 5:30 is very worth it. I'll just be honest. Yeah, 5:30 is definitely not worth it. How much time do I have left? 21 minutes. Yeah, I can just chill. Doesn't really matter. I mean, okay, you know what? I will try to mind solve the full 100 on F. I think it should be fine. Or like, I know how to do subtask 2. That's just a dp of node comma depth at which the headquarters is. But the details are horrendous, so yeah, maybe not. The details of that are actually horrendous. And okay, for the full, you obviously can't maintain any notion of like, you can't maintain any notion of like of the depth at which the centroid is, or the headquarters, whatever. So yeah, I don't know. It's like at each guy you just position a center. Maybe centroid decomposition is helpful here. Je ne sais pas. I don't know. I don't want to think about this problem. .515 can't be bad. Like, there's no way that 515 will be a bad rank. Or, I don't know. Okay, let's think about full. But it's also weird in that they can be like within one. They don't have to be exactly the same depth. There's technically a linear amount of states, I guess, because the sum of the depths is like, okay, if you condense the tree in such a way that each boundary edge is now a node, the P node depth now has a linear number of states, and the transition is doable as well. Sure. So honestly, in reality, like, the 70 and the 15 are have similar like amounts of grossness. Like, they're not too like different in implementation difficulty, at least the way I see it. Yeah, not too different in implementation difficulty. So I don't know. It doesn't feel to me as if implementing 15 is that worth it. I might end the recording at 2:50 because I don't expect to make any more submissions by then. Yeah, by this point, I've mind solved P6, I think. Yeah, I think this mind solves P6. But yeah, I think like I'd only really want to implement this if I had like another like 40 minutes or something. Otherwise, yeah. At this point, I don't think I'd get much enjoyment out of doing it. Anyway, I'll go over how I did each of these, I guess. So for this one, you just notice that for every pair of adjacent positions that can be preserved, you decrement 1 from the answer. For this one, you win if and only if the number of ones is odd. For this one, you notice that an array is good, like a number is like deletable if and only if its initial index contains all of its divisors, or more specifically, all of its prime factors. So you end up with a situation where like for each number, the begin point has to be at least some amount far back. So you can get like the minimal amount back that a subarray with an index needs to be, and then you can like just accumulate a count from there, like by chaining. It's like DP on a linked list, if that makes sense. For this problem is actually pretty cool. So if you don't care about the distinctness, the answer is just the number of staircases from 0, 0 to n comma n. And if you need distinctness, you can notice that like there's like a bottom quadrant of the grid that has to be monochromatic if this distinctness thing has failed. And you just do like some really basic inclusion exclusion to count out the non-distinct cases. For this problem, it's like a greedy algorithm. So basically, in almost all cases, you can always remove an edge that's not in T from S and add in an edge that wasn't originally in S in such a way that constantly makes progress. And the only case in which you can't make progress in one move is if initially all edges in the soul cycle of the graph are already in T, in which case you have to sort of take one extra move to make a cycle that's workable. So in that case, it's the number of moves is T set difference S minus 1. Otherwise, it's always going to be T set difference S, which pretty clearly seems optimal. And this P6 I've been talking about for a while. So, all right, 8 minutes left. I'm probably just signing out. See ya.